Do the NSA run a secret virtual machine on your computer next to your OS? Today we're going to dive into another hidden operating mode of Intel CPUs, Secure Arbitration Mode. But first, let me show you how it works on the blackboard. Sup guys, welcome to today's show. So, today we're going to talk about something I found in this manual. The Intel 64 and IA32 architectures, blah blah blah, volume 3C. And especially a chapter, this, SEAM, Secure Arbitration Mode. And you have probably heard about SMM, which I made a video about the other day. And you have probably heard about Intel IME, which is a small computer living inside of your computer. But have you heard about SEAM, which is the most scary of them all? So before we check the manual, I'm going to discuss this a little bit. So SEAM is a special hidden operating mode inside of the Intel CPUs. And what it does is it mimics another technology which is called VTX, Intel Virtualization Technology Extensions. It's also called VMX. That is how you run a hardware-based virtual machine on Intel CPUs. And SEAM is based off of this technology, but has some important, very odd differences. So what it does is it's creating a hypervisor and this hypervisor is called it's called SEAM root operation. And this is a hypervisor which is totally transparent to the underlying virtual machines that it runs. And you cannot even detect that SEAM is activated. And the only thing that can activate SEAM is your BIOS. So your BIOS boot sequence can activate SEAM. And then it will create a virtual machine. And inside of here, it will put your entire operating system. And it will assign a piece of the hardware memory addresses. And to this virtual machine where your OS is running, it looks like this is the whole memory space. So you can't detect that it's only a part of that memory. And it also runs another virtual machine simultaneously with your OS. And this is called the SEAM guest. And this is a piece of software which runs next to your operating system all of the time, and you can't even see that it exists, and it can do pretty much what it wants. But what the hypervisor does is it creates a memory space for that virtual machine as well. But this memory space is very different. It is called the SEAM range. So it's a range of hardware memory addresses in RAM, which is allocated to this special virtual machine. And the interesting thing with this memory range is that it is encrypted. And it's not encrypted in software, it's encrypted in hardware. So your CPU, each time this virtual machine tries to read or write or execute code in this memory range, your CPU automatically will decrypt and encrypt this memory. So if you were to look at this memory space from, let's say, a special bootloader or something, you would only see encrypted gibberish. And the encryption key, let's say it's something like this. It is stored inside of the SEAM hypervisor, the SEAM root operation. And you cannot read this memory address. If you try to access this, it will cause a general protection exception inside of the CPU. And if you somehow bypasses that, let's say you modify some MSB in the boot sequence, or you poison the cache somehow, then if you try to read from this and actually execute a read instruction, it's going to fail silently. So it will go through, not produce an error, but it will only give you 1 bit as output. And if you try to write to this location, it will not fail either, but it will not change anything. So it will silently fail. So why does this exist? Well, it's kind of hard to tell, because to me it looks like it is specially crafted to run some nasty backdoor code Trojan inside of here. But that part I don't know. But the rest of this, everything that I have told you, is inside of this manual right here. So it talks about the SEAM root operation, that's the hypervisor, and it in turn has 2 different modes. There's a loader mode that only one processor can be in at any time. So that's basically like the kernel, so to speak. And then there are a couple of modules inside of the hypervisor, and this SEAM guest can call into this hypervisor and ask it to do things like make a report of other virtual machines running on the system, like this Windows right here, or it can ask for other stuff. And it says here certain platform operations may be required to enable SEAM. So it doesn't say how it's enabled, only that certain platform operations is required. And until they are performed, SEAM may be globally disabled. That's also an interesting choosing of words, because Intel is very specific with what kind of words they choose, and may be globally disabled. So that sounds to me that like it might also always be enabled, no matter what you do. And there's this SEAM call, CPU instruction, which it can use to call into this module. And there's also something called SEAM ops, which is another special instruction that it uses when it wants to call into the kernel mode here. And here it discusses the multi-key total memory encryption, the TMEMK. That is what's encrypting the memory by the CPU. And software in SEAM cannot leave the virtualized environment. And this is also interesting, because I talked about NMIs in my other video, which is a special type of interrupt which starts the SMM mode. An entry to SEAM root operation blocks NMIs. So system management interrupts are masked in SEAM root operations. So the first thing the hypervisor does when it starts up is it blocks all entries to SMM. So you cannot go in that way, so to speak. And here is what I said before. Outside SEAM root operation, access is to the physical addresses in the SEAM range, that's this, are aborted, meaning that writes are ignored and reads return values with all bits set to 1. So that's kind of sneaky, right? And it says that the encryption key is machine specific. And it's typically an ephemeral key. That's a temporary key which is generated each time the platform is restarted. But it's typically an ephemeral key. That says to me that every machine has its own key, and someone has that key, right? And here is also about what I told you, that you cannot access the encryption keys inside of the hypervisor. And here we talk about the SEAM call, which is to call inside of these modules, inside of the hypervisor, and SEAM ops. This is interesting. Execution invokes SEAM specific operation. It is used by SEAM modules to execute such operation. That's the only thing it says about it. Specific operations and to execute such operations. Okay, that tells everything, right? So, very interesting mode. And please tell in the comments if you have any thoughts about this, and if you know something relevant to that we can make maybe an additional episode about. So please don't forget to like and subscribe, so I know that you are interested in this stuff and that I want to look for more secret operating modes and similar things. And thanks for watching. Thanks for today.